problem to be solved.
Okay.
Hi, hello.
Hi, hello.
Good morning. Thank you for coming.
Good morning.
Sorry. Some flights are being cancelled.
Your flight?
No, not mine, but Tommy. They try to arrange the schedule for a video. Okay, so everything is okay with the...
Yes, looks okay. Yeah.
Excellent.
Mm-hmm.
So let's... excuse me? Let's see, just a few minutes. Okay, so let's wait a few minutes.
Okay.
And then we start.
Sure.
So good morning, everyone. It's about time to start the session, but we'll wait for a few minutes. I know that some people got late to bed last night, so let's wait some more minutes and then we start. Thank you. After the keynotes, at the coffee break, I would like to take you to what we call the video blogs.
Okay.
So just to do one short video, 1 minute, and I'll be asking what are the main takeaways, the main messages from the talk. Okay? And then we put it on the conference website.
Okay.
Okay?
Sure. Thank you. Okay, so maybe I think we can have a slow start of this session. So good morning, everyone. So I'm Luís Correia with IST, the University of Lisbon. And it's a pleasure to be here with you today, serving as a chair for this session for the two keynotes of this morning. Just a minor note on the side, if I may. Scheduling keynotes is always a tough puzzle
because you have to accommodate the restrictions of the speakers. So it ended up to be like these, given the restrictions, the speakers of the previous days. So it was just as simple as that, concerning the way that the keynotes have been scheduled, nothing more than that. Okay, so we have two keynotes for this morning, as you have seen, and the first keynote comes from Ruyue Lee. I'm not sure if I pronounced your name correctly. My apologies if I didn't. So Ruyue Lee comes from ZTE and is currently the Senior Managing Director of Radio System Standardization, so ZTE, of course. So he's in charge of research and standardization on radio systems related to 5G and 6G technologies. He got his PhD from the University of Hong Kong. And I will not go through the whole CV just for the sake of saving time. You have the CV of our speakers in the website. So without further delay, I will give the floor to you, please. Thank you.
Thank you for introduction, and hello everyone. Good morning, and thanks for having me here. My name is Ruyue Lee from CTE. You can also call me YN, and I'm the head of radio system research and standardization. Currently in charge of research and standardization on radio technologies targeting 5G Advanced and 6G. So it's my pleasure to here to show our views on and thoughts on 5G Advanced and 6G. The title of my presentation is Evolution of Emerging Technologies Towards 5G Advanced and 6G, the Continuation of Paradigm. So indeed, we think transition from 5G to 6G is a continuation of paradigm, and it's a gradual and smooth evolution process. So let's have review on a little bit on the evolution path of telecommunication system. So far, each generation we have something new. So in 3G, we started to have this mobile internet. And for 4G, we enable more internet applications with higher bandwidth and have initial extension to use case like IoT. And then in 5G, in addition to enhancement on this eMBB mobile broadband, we also aim to support new scenarios like MMTC and URLC in order to have vertical penetration, including industrial IoT scenarios. While we are still exploring further 5G applications, we also have started to explore and discuss 6G use cases. We expect 6G to have more integrated functionality in a native manner, including aspects like communication, sensing, intelligence, computing, and security and power. So basically, these features are native features, which is growing like naturally inside every 6G systems. We call it Compass with native CSI, CSP. And then in the 3D graph below, the requirement on these three domains, including connection, storage, and computing, are expected to be growing exponentially as it evolves to next generation. Then this slides, let's go over the 5G Advanced and 6G standardization roadmap and timeline. So this is our estimate on the timeline of 6G standardization related to two major organizations, so namely ITU and 3GPP. And there are ongoing activities in ITU-R, Working Party 5D, including trends and vision we are now working on. Once these are done in the first phase, we will go over to the phase of further study and evaluation preparation, and including defining requirements, setting up evaluation details, and submission templates. So after that, it is expected to have a workshop which that ITU-R explain outside to the process about the process of evaluation and submission. So typically, it provides opportunities for organizations to show their intention for submission of 6G proposal. Then the window of submission of technology proposal will be open after the workshop. And then, so with this window, the evaluation on the first batch of submission and a specification process will then follow and get finalized towards 2030. The details of these blocks are still being discussed in ITUR. Actually, it would be another 5D meeting next week. And from 3GPP side, there's some interaction between ITU and 3GPP. The discussion will start a bit later, we expect like 2025 or 2026, depending on like which aspects. So we only show here the WAN timeline aspect, radio access network aspect. But prior to that, we also expect some initial study on the use case and requirements in SA1 group, which is not shown here, but we expect it will pretty much start in 2025. Then let's focus on WAN timeline now. And then for WAN timeline, we expect there's also requirement on WAN aspect in 2026, which is pretty much aligned with 1 decade cycle from 5G. So in 5G, we start in 2016, around that timeline. So then it's desirable to have this work item, follow-up work and study item on technology proposal, including architecture and also WAN aspect. After this requirement, and also we have this study phase and then work item phase, which means the standardization is done from 2028 to 2030. It would leave pretty much more time for 3GPP to deliver 6G standard, which is targeting to have a stable and competitive enough in the market for subsequent commercialization. So in this graph, along with this 6G timeline, along with this 6G timeline, we also show this 5G advance. So we think there will be a parallel process for 5G advance, spanning from 2022, which is now, and towards 2030. So next night, I will talk more about this 5G advance. So this slide, we show the estimated timeline for 5G advance release in 3GPP. So 5G advanced is a new 3GPP marker which aims to provide momentum to ensure sustainable 5G market. So in our view, full 5G advance, it is important to make 5G truly useful, including verticals and covering large variety of use cases. So sufficient time should be given to 5G advance so that technologies developed for 5G advance can be well utilized before proceeding to 6G. As you can see from the graph, 5G advance starting from release 18, and actually this week 3GPP has just announced release 17 freeze in WAN, and then all the working groups will start release 18. That means it marks the milestone of the starting time for release 18. Then after release 18, we expect 4 more releases will be still ongoing. So many of we realize many of these so-called 6G technologies under discussion actually can be built in on top of 5G framework within the 5G advanced timeline. So this can be used to bridge the gap between 5G and 6G transition period. So we should also ask a question to ourselves. So why shouldn't we consider these technologies for 5G first, and so that we can truly, fully maximize benefits and return from our 5G investments? So from our view, there are no big hurdle on considering many of these technologies for 5G advance. So we will, in the following slides, we will give some examples. So first, we show here what's expected in the 5G advance, and this is the Release 18 package projects approved in December last year in VGPP. And the kickoff of some of these work items already start in physical layer aspects. And many topics are further enhancement, as you realized, based on the technologies introduced in previous releases. Like MIMO here, we have MIMO every release, 5G release so far, but we can still see some good demand on potential enhancement, especially on uplink side. So uplink MIMO, together with multi-carrier enhancement and coverage enhancement, for these items, more focus will be on uplink, which is found as a bottleneck for scenarios with uplink heavy traffic, like machine vision. So some other topics are enhancements for verticals. So basically, like reduced capability UE for verticals applications like sensors, and Silink enhancements, etc. So more, and these are the basically enhancement based on the previous releases. And more importantly, highlight in the upper table, we have these new WAN topics introduced in WAN at the first time in Release 18, like artificial intelligence or machine learning, smart repeaters, full duplexes, extended reality, including AR and XR, AR and VR, and energy saving, etc. So for the first two, I will discuss a little bit more into more details. Then for full duplex, the third one, basically we start with subband full duplex at base station side in Release 18, where uplink reception and downlink transmission at the base station side can be done at the same time, but with different subband frequency resources. But then going forward, we expect more advanced frequency overlapping cases, and also at the UE side, full duplex case will be considered as it evolves from 5G advanced and to 6G. So this is also one of the example technologies that that's a transition from, when we transition from 5G advanced and 6G, we should pay attention and consider. And for XR, it has been discussed to support XR-specific enhancement on, for example, QoS, network capacity and power saving, resources allocation, etc. So these are also together with this hot topic metaverse concept. We think it's also like one of another example that like it will span from 5G advanced to 6G. And for energy saving, it's always an important topic. We consider energy saving especially at the network side in this Release 18, in addition to the consideration at the UE side, and And this also aligns with the goal of reducing carbon footprints going forward. So this, in the following slides, I will also introduce the machine learning and smart repeaters and with. So then this example basically is you can start realize these features are somewhat overlapping between 5G Advanced and 6G. So then let me go over another two examples in more details. So this slide is about AI ML. This one we as described earlier, intelligence is one of intrinsic components we expect in 6G. So it's like naturally built in in all systems and in all application layers and applications and layers. And for example, XR, IIoT, V2X, UAV, you name it, pretty much you can find some potential AI application in all these scenarios. So AI is expected to be the core functionality with standard support in 5G Advanced network. So in order to make AI intrinsic, we start standardization effort with some use cases in Release 18. For example, in WAN network, we will proceed to the standardization work for use cases of network energy saving, load balancing, mobility optimization. This is from the network side, and for the air interface side, we have another project on air interface in Release 18. We will start with the use cases of beam management, CSI acquisition, and positioning. So here we illustrate 4 examples of potential standardization impact. One possibility is to have an AI model transparent to the standard. So it is up to implementation at either at base station side or UE side. So the what standardized air interface will just carry information to assist AI on either side. In first example, feeding back information from UE to assist AI at base station, where training and inference are both done at network side. Then after that, the second example is for the network to deliver the outcome through downlink signaling, like signaling for prediction. So this pretty much transparent to whatever AI model is used is transparent to the standard, but some signaling can help. And in the third example, AI ML training is done at UE side, and also inference is also done at UE side. And the feedback is provided by UE based on the output from the AI processing at the UE side. So this is also transparent. AI model is transparent to the standard. So in the fourth example, we call it a collaborative AI. So this the AI model may be somewhat non-transparent to the standard. The training is done at the one side and inference is done at the other side in this example. So the standard may provide a container to download AI model to sync up the model used in both sides, and split in inference is also one possibility. Then how to split inference should be discussed for standardization. There are more standardization impact on air interface expected going forward. For example, distributed AI and also federated AI. So we expect there is a good chance that we will start with something simple on standardization impact in 3GPP for Release 18 in 5G Advanced, and continue to evolve to 6G, then in 6G we will get more comprehensive support of different types of AI model in standard. So our eventual goal is to make AI intrinsic. That means support AI everywhere, covering massive variety of use cases. My previous slides are more on the aspect how to design and make use of AI to enhance communication system. That is AI for 5G advanced. For example, how we predict beam with trajectory, or how to predict mobility so that we can do data transmission more efficiently and robust, more robust. So if you will, it from another aspect, we need to consider how to design our communication system for better support of AI. So for example, when we do machine vision in IIoT use cases, there can be different need on how inference is fit on the network. Then the user considering trade-off of data volume, capability, and also capacity support at each side. So if we want to support such AI-based services, we need to understand the traffic characteristics of AI and adapt our communication system to optimize the support of such traffic. So going forward towards 6G, we expect these two perspectives will continue to be taken into account. We may focus first for AI for the communication network in 5G advanced, but going forward, I think both aspects would be equally important. And the next example technology that we think it will start to be introduced is reconfigurable intelligence service. So WIS has attracted the attention of academia and industry recently because it can flexibly manipulate the electromagnetic characteristics of wireless channel. So applying control signal to adjustable elements on these units, the properties of these units can be dynamically controlled, so as to realize the intelligent regulations of space of these electromagnetic wave in programmable way, and form an electromagnetic field with controllable phase, polarization, and amplitude. So as showing here, we have, for example, these two-dimensional implementation of metamaterials. So WIS naturally has the characteristics of low cost, low capacity, easy deployment. And in release 18, actually we start smart repeater, and we expect it will serve the basis of future standardization support of WIS here. So standardization will focus first on side control information delivered from base station to smart repeater, or WIS, to control the operation of the repeater. So this is different from traditional RF repeater, which does simple amplify and forward without control from the network. Here, the control information potentially can include like beamforming, timing information, TDD configuration, on-off and power control, etc. So through this standardization support of repeater, this will set up basis standard support of WIS, considering beamforming is the major feature for both repeater and WIS. So more advanced beamforming control or coordination for WIS can be developed and evolve in standards. So with mostly passive components and large-scale antennas considered for WIS, we can also achieve green massive MIMO solution with ubiquitous antennas for coverage, for throughput, and for energy efficiency. Here we show that the UE under blockage in line of sight can get coverage due to reflection from width. And also for another UE, we can get multiple paths so that spatial multiplexing can be achieved for better throughput in the middle of this graph. So width basically has been a hot research topic recently, but in fact, this is not only staying in research papers. At least from our side, we have done both simulation and prototyping verification and field tests. So we have verified those benefits from width. By simulation, for example, here we do some ray tracing based on some real urban environment. Here we illustrate that with width there are less blind spots in the left-hand side of this first graph. And then we also show that UE-specific bin tracking can be achieved by controlling the bin from width towards moving UE dynamically in the graph in the right-hand side. So in addition to simulation, we have already done some field tests covering both millimeter wave like 26 gigahertz and mid-band of 5G like 3.5 gigahertz. It can be observed that, like in practice, we can simply put a width panel between base station and UE, which does not have a line of sight in between, like showing in the graph in our campus in China. So, for example, when the UE is in a hallway inside an office building, there's no line of sight from the base station. Then we can put a width panel at the entrance of the building, where signals can be transmitted from the outdoor base station and reflected to indoor UE without the need of line of sight with base station. So another example here is that the UE is in the blind coverage spot outdoor. Through deployment of width, the UE in blind spot can be covered. In general, we observe something like 10 dB to 20 dB of RSRP improvement. So cell edge UEs or UE with poor coverage can get significant boost on the throughput. For example, free flow increase. So with these field tests, with prototyping, it's expected that commercial deployment doesn't need to wait till 6G. We can start in 3G advanced timeframe, and it will be further extend to more use cases and application in later stage of 5G and 6G, and then 6G. So here we show some use cases and applications. As I mentioned before, for more traditional application in cellular network, width can achieve the purpose of coverage enhancement or extension. It can cover coverage, hold, and blind spot. It enhances cell edge performance, indoor coverage. It can also enhance reliability and MIMO spatial multiplexing for multi-stream for better throughput. So it enables more advanced MIMO processing and beam management here. And going forward, we can think about more newer with application, like in addition to traditional cellular application. So for example, here we show like integrated sensing and communication, which can act as assistant node to assist sensing and communication in scenarios with obstacle or sensing with higher accuracy. So similarly, high precision positioning can be also achieved with massive MIMO provided by WIS. It can also provide sensing of verticals, vehicles without line of sight in V2X or UAV scenarios. So fine beamforming nature of risk can be explored for application of energy harvesting, and also passive backscatter communication can be achieved with risk as well. So there are many more potential future applications explored in 5G Advanced and 6G. We think 5G Advanced may take into account some of these, and then we expect this technology will keep evolving to more and more application in the future during the process of evolution process to 6G. So we have gone over 2 examples mainly, but in addition to these 2 examples, there have been discussion on many more other potential 5G advanced topics. For example, integrated sensing and communication, energy harvesting enabled communication, and metaverse. These have been approved in for Release 19 SA1 project in VGPP for identifying the service requirements and use cases. So we expect some follow-up standardization process for these new technologies will be start in 5G Advanced. And there are many more topics like mesh network, distributed data management using blockchain. These services and functionality can be also built in on top of 5G framework, so that in our view, the evolution or transition from 5G Advanced to 6G is expected to be gradual, and along with these new technology, consider both for 5G Advanced and 6G. Okay. So after reviewing some 5G Advanced timeline and technologies, let me go over more quickly over some of our preliminary thoughts on 6G. Like 5G, we expect 6G will continue to be one of the major drivers of global economic growth and plays a very important role in achieving sustainable growth in many other aspects. A new round of innovation will help digital industrial revolution by enhancing its productivity. It ensures community with intelligence and efficiency. So when we develop 6G, we should keep in mind on the environmental friendliness and digital equality. Ensuring global partnership is particularly important as well. It would be essential to build synergy among all the stakeholders to ensure consistency and avoid duplication or split. These are pretty much aligned with sustainable development goals set by United Nations. So with these high-level principles in mind, when we design 6G architecture, the following aspects should be considered. First, of course, we need to ensure ultimate performance compared to 5G and intelligent interaction considering different senses like touch or smell. Then we expect to cover more extensive spectrum in 6G. We expect global seamless coverage, more integrated terrestrial and non-terrestrial communication system to cover location in the air, on the land, and over the ocean. With the surface-based architecture, then we expect 6G architecture will, with more surface awareness, high agility in terms of adapting dynamically to different requirements in autonomous fashion. So then we will have these intrinsic capabilities as we described earlier. So here in this slide, we use this Willow triangle to illustrate the relationship of 6G and 5G and represent agility of 6G. We have 3 considerations here: enhance, extend, and exceed. So based on the 3 usage scenarios from 5G, we further enhance these scenarios in 6G. Then in 6G, we extend frequency domain to cover a new spectrum like terahertz, extend spatial domain to have advanced utilization like holographic radio. Then we integrate all types of communication system, to support combination of these three scenarios in 5G, and also have this integrated functionality. Then we exceed 5G to have these intrinsic capabilities like AI service and security, as we described before. So then in the right-hand side, we show our preliminary thoughts on 6G requirements, which will involve many aspects. In the interest of time, I am not going through the details of each of these requirements, but I just want to point out and highlight that like many of those enhanced requirements compared to 6G and compared to 5G, like data weight, which is 100 times enhancement, and some of these requirements are new to 6G. For example, sensing resolution, or some consider in 3D granularity instead of 2D. With these aspects, we think these new requirements we should pay more special attention on. So without doubt, this is a challenging set of requirements to be met in 6G. Then I guess next question would be, what are the enabling technology to meet these requirements? So these are a big question mark of going forward. I think starting now and going forward to be considered, like to study these enabling technology, including the technologies we described before. So we believe the technology shown in this slide is quite a common set of technology we consider in current multiple 6G discussion platform. Like I said before, some of these overlap with 5G Advanced. But in 6G, we expect higher flexibility without the limit bound to originally 5G framework. With some concepts are expected to be based on evolved technology from 5G. Some other concepts are relatively new, like computational, holographic radio, digital twins. So we don't have much time to dive into the details, but the conference like this provide a good platform to discuss these future technologies. So last but not least, I would like to further emphasize the importance of global cooperation. So different regions have different platforms to conduct these and study beyond 5G and 6G technologies. Like, for example, I list here the platforms in Europe, here, America, and Asia region. Despite of these, eventually we hope all the stakeholders and participants from different regions can collaborate in global platforms, including ITU and 3GPP, to create one major 6G global standard under which these stakeholders can collaborate and continue to have this healthy competition in the ecosystem we have developed in the past generations. So with consideration of sustainable supply chain and development of regulation considering technical and commercial aspects, it would be useful to have this kind of also conference like today, which we can exchange our views and thoughts to converge more on technology routes for 6G before standardization process. So yeah, so basically this pretty much concludes my presentation. Thank you for your time, and it's my pleasure to present our views on evaluation of 5G towards 6G. I hope you find it interesting. Thank you.
Thank you very much. So, I think I speak loud enough, right? The floor is open for questions. Anyone? Yes, please. Can I have a microphone? No?
It's on the table.
Okay.
Thank you. My name is Jaeun Jung from the LG, and I'm pleased to see that you are overlook for the 3GPP standardization movement. But most of the 3GPP guys and the advanced R&D managers big interest for the forecast of around the year 2025. And in that sense, and then we can remind us some situation in the 4G LTE and the 5G transition around the 2015. In time of that the most of the 3GPP guys very similar view like you presented, but eventually the substantial portion of standardization effort is moved to the 5G NR specification. So if there is any difference around the 2025 compared to the year 2015, and could you elaborate about what would be some different situation in the 5G advance to the 6G transition? Yeah.
Thank you for your question. Let me clarify. Try to clarify what you expect. So when you say difference in procedure-wise, is it in procedure-wise or in technology? Yeah, sorry.
Yeah, I'm just now the a little bit focused on the some 3GPP standardization effort. In time of year 2015. You may remember the situation with LTE advanced is very popular at the time, but 5G NR standardization is initiated around the year 2015 and the year 2016. In that time, the initial view is somewhat balanced work between the LTE advanced standardization and the 5G NR standardization, but eventually, when it comes to the standardization effort, is moved to some new version of 5G NR standardization. You can remember this time. So, but your provided view is some little bit more 5G advanced centric view, and then if we can guess that 5G advanced standardization work is still very, very active compared to the 6G standardization. What is the main different situation from this compared to the 45G transition?
I get your question now. Thank you. So basically, what we think at compared to 4G to 5G transition, the differences like in 5G, we aim to cover more use cases and application like URLC and MMTC. But I think these applications like targeting in verticals segment are not really like I would say like it in a full run, and it just started to be considered in the industry. But so we will expect it will leave more. We should leave more time for particularly in vertical applications to get more mature, so that we don't waste the effort on 5G. So including this 5G advanced effort, also there's some enhancement, particularly on vertical applications. So I would say this is one big important difference. and similarity, I think we can also reference what we happened during the 4G and 5G transition period. So in 5G, we at that time we see a hot demand from either academia and industry, but then so in standardization we rush to have this multiple release or multiple drop, but and looking back, we see like it actually is not good for the new generations. So we should leave more time for study and also standardization, and to have one full good release and stable and competitive release. And this, I think, is a good experience, lesson learned from the 4G and 5G transition period. That's why here we emphasize that, like, although we start 6G study and research, even standard, we are talking about how to manage the standardization. We should not deprioritize 5G effort, and otherwise it would jeopardize our investment and effort on 5G standardization. Yeah, thank you.
Thank you. Any last question? Just not to be too much delayed in today's session. Okay, one more question. Okay. Last one. Sorry, guys.
Thank you very much. You mentioned your enabling technologies for 6G, one of them holographic radio. There are different point of views on what the holographic MIMO or holographic radio is. Would you be able to provide a little bit detail on and clarify what you think holographic radio is? Thank you.
Thank you for the question. So I guess we have no time to go into details, but roughly in high level, what we perceive is holographic radio basically consider consider the spatial distribution of the antennas, so that it can like basically kind of doing like 3D shaping on this channel, so that it can be in terms of MIMO, especially for considering, for example, channel estimation, and also this also maybe physical layer concept of also the digital twins can be done along with this kind of holographic radio technologies, and also this in more high level in terms of service. There's also holographic terminology, meaning that we basically replicate what we have in 3D shape, like in metaverse scenario. So this is more in physical layer, is more into the sense how to make use of this distribution of massive MIMO based on the phase and polarization, all these, to be more accurate to replicate or estimate the channel, the 3D channel experience in the real world. Yeah, thank you.
We have to close this part of the keynote. Thank you very much again.
Okay. Thank you.
Thank you. And now we move to the second keynote of this morning, which is coming from Egon Schulz, which I have to confess we know each other for many years. Yes. Since Egon was No? Okay. As I was saying, okay, sorry. No. So Egon has many years of experience in mobile communications in general, and he currently serves as the director for the research center of Huawei in Munich. So everyone knows Egon and his CV, so I will not spend more time on that. The floor is yours, Egon, please. Thank you.
Okay. Thank you, Luis, for the introduction. So now I have to look to my laptop. Yes, it's okay. It's coming. Okay. Good morning once again, everybody. I see a lot of seats are occupied, but the rate is not so high, but I think that's the last day and a lot of people departed yesterday. My name is Egon Schulz. As Louis said, I have a lot of experience. I'm with Huawei since 2009, and before this time I've worked for two European companies. It's called Siemens and Nokia Siemens after the merger. And then they opened Huawei Research Center, and they have looked for a guy, and then after some assessment, I got the jobs, and I'm happy to do it. So, now as Louis said, we have the mobile communication story is not so old. It's already now, I say 40 years old for the digital mobilization, and the digital mobilization is a mass market. And the digital mobilization also pushed the digital evolution. If I look into the prices for the first digital mobile, that was around 1,000 euro. That was very, very high prices. And then Motorola came in the market and they decreased the prices of the mobiles. And then at the end, there was around 200-300 euro. I was involved also in 1G. And 1G, the German C network, that was a digital system, not an analog system. The voice was also had the speech coder, and the protocols was also digital. Then I moved to 2G, and 2G was the system which I was educated. And with 2G, we had the big success. This was a pure European system, developed by a lot of European companies. Most of the companies doesn't exist, and doing mobile communication. And here we also learned a lot of topic what the user are using. But in the first topic we had only some voice. Later on we increased it by data, then we had some edges. But then from 2G to 3G, what I heard also in the last years is why we need a new system. Everything is working very well, why we want to go to the next system. It's every time the same. And if the system deployed, then the people saying, the CEO saying, oh, this system, we will make no business. So every time the same game, why we need it, and in the first step, we will have make no business. Then 3G. 3G was after the success of the European system, GSM. GSM was a previous operation for Group Special Mobile, because that was a cooperation at first between Germany and France. Then we had here, then more and more player came into the system. Then there was a connection between the Nordic countries and the Asian countries, and on the other side, Central Europe with the US. And at the end, we had the system which is called wideband CDMA, but with a very bad performance. But later on, we improved it by HSPBA in order to support higher data rates up to 40 megabit. So and then we moved to 4G. 4G was, I want to say, a paradigm changing. We moved more to a packet-oriented system. That was the one step. And the second step is we also want to have high data rate. And for example, my boss said to me, why we need 4 antennas? That costs a lot of money, amplifiers, and so on. And then we had also discussion with the customer. The customer said, why we need 1 gigabit? Where will use it? We have no equipment, we have no mobile phone which can support 4G. But with the possibility to develop highways, we had the possibility to develop smartphones, and Apple was one of the guys. He earned, I want to say, the money. He said, I will give you a computer, and with this computer you can make also mobile phones. Phone calls. That was the idea behind this. Yes, and then 1 gigabit, that was the limit, and now we go to 5G. 5G is now deployed, and that can support more than 1G, but the difference between from 4G to 5G is that in this area, I participate in several car-to-car communication projects. And one of the vendors also said you can do everything by OTT, but OTT is not very efficient for the car-to-car communication. If you make a braking and you have to form your guy in the back, he will not recognize this too early. So in this case, then we said, okay, we introduce two new services. One service is low latency with up to 1 millisecond, and also high reliability. If you want to have a connection between two machines, then the connection must have high reliability. So, and now we are going from the 5G to 6G. That will be maybe deployed 2030. And here we introduce also new services and a better 5G. A better 5G means we want to go in a very low latency, and we want also to increase the data rate. And we will also introduce two new features. It's called artificial intelligence and sensing. With sensing, we have the possibility to make an overview of our environment, so we can recognize what is in our near in our near landscape. So that means we will also go to will introduce new features. But the point is, yesterday we had a keynote speech that was from Falco, and I have seen the first new sign 6G+. So this means some people thinking about what is 6G+. They want to integrate, maybe some people participate in the keynote speech. They want to discuss about nano communication, the communication in the blood, in the body, in order to make more sensing. So then, what are we call this connected intelligence or intelligence native? So we have the native IE. Then native IE, we will see that the system will have not only communication, we will have also computers and storage and also sensor technology in, and we have to define the system in an intelligent manner. Then network sensing. This network, we will go to wider bandwidth, we will go also to higher bandwidth, and with this new interface or with this new technology, we can, I want to say, sense the environmental, and then each sensors or each devices can send the information to the network, and then he can build imaging, or he can make a spectrogram, he can make parameters, so you get all information with artificial intelligence and with in a corporate manner, a whole picture what is ongoing. So then we are going to the extreme connectivities. So everybody has not only one mobile, he has several mobiles, he has also some sensors at home. You must connect all these things, and also the network must support this. And another big challenge is here, if you have a huge data, you must also to transport the data. So this means we are also going in the direction of the performance of optical fiber. Then sustainability, that is one important topic, sustainability and humanity goods. On yesterday, on Wednesday, we had a panel discussion. Should we go every time in the direction to save energy in the system? There exists also the possibility to use more energy in order to serve other tasks. And there must be a trade-off. For the time being, we every time discussing about the energy saving, we should not use more energy as the last system, we should reduce it. But what is the advantages? If you're reducing the energy, can we then solve more tasks? That is also a paradigm changing. We have to think about in which form we can use our network in order to fulfill the climate changing. Then we have trustworthiness and resilience. That is now, for the time being, a very important feature, in particular based on the geopolitical discussion between US, China, Europe. Everybody is now looking in his own back, he wants to say we need trustworthiness, there exists a possibility to do it so that you can trace every action, every protocols in order to fulfill the requirement, if you want. Because there exists also the possibility to say, yes, I want to have it, but I don't support it. Then we have satellite, and the satellite is a very important feature for our future. I had several discussions with Orange. Orange's slogan was, connect the unconnected people. And with the integration of the non-terrestrial network, we have the possibility to integrate these unconnected people, and also we can use this for the mobility of the trade exchange on the sea. Yes, so that are the 6 pillars which we consider should be a part of 6G. So, we also discussed about 5G in the previous presentation. The 5G, we have the mobile broadband, we have the massive machine type communication and the ultra reliability. So we will have in 6G a better 5G with higher data rate, peak data rate up to 1 tera, but we will have higher connectivity, extreme connectivity with where is it? Here, with a massive machine type communication. But we will have 2 additional features. Yes. And when we want to have 2 additional features, we must have a new system which supports this interface. You cannot build in this in the 5G system because 5G system is not prepared for this. And the lifetime of a 5G each system is around 30 years. So in this case, we want to have the artificial intelligence and also sensing technology. So now I will discuss, Louis, how long time I have? Until 10:30 or? 10:30. Okay, good, thank you. So then native AI communication. We have here a human, here we have a robotics, and we have the normal channel model with the noise source. The system should only not the data pipe for machine learning, but this model should also give the information or to derive the artificial intelligence or the neuronal network. And then between the 2 guys, then I can make semantic communication. I can say to the machine, please bring me a cup. Then he knows I want to have a cup of coffee without milk and without sugar. If I say another word, then he knows that. He knows also where is the cup, so he can do it everything because with the artificial intelligence and of the learning of the neuronal network. So, that is a nice picture in order to look how we want to build this neuron center. This neuron center is the artificial intelligence center, where we have this center has learned from a huge number of users what is their behavior. But very important is in order to fulfill the data security, not to transfer data. Here we have no data. That is pure AI modeled system. It's neuron center. Where is it? I don't know. It could be in the Google platform. So, and this neuron center, they need a lot of computer power to do it because you will get from the neuron edge, maybe that is one operator, that is a second operator, 2 models, and you have to shape the 2 models together. And you need a lot of computer and storage. But who can do this? For the time being, I only see that Google or Amazon can do that. And that is here on the private side. The system developed on the device, they've developed based on deep learning, the models, and then several devices come together, and then they make a shaping, and they make a federation in this model. And the data have to keep here in the private zones. No data should go outside of the private zones. That is a very huge requirement. So then we are coming to the next pillar, that is integrating and sensing with a new system where we also integrate terahertz communication, maybe also optical wireless communication. Then we have a lot of devices which can sensing the environmental around, maybe in a huge distance or in a smaller distance, and then you can bring it to the network, and within the network then they can exchange the information, and the green bond that are the sensing data, that is a huge number of data, and also the red bond, that's a communication, so they make a communication between all devices. But the idea, the technology behind this is the same which we are using in 2G, to cooperate the information of two different senders and to make a clear picture or to improve the performance. So in this case, we have also bidirectional sensing and unidirectional sensing. That is what we are called also crowdsourcing and federal sensing with from billion of devices and the network as sensor. So what we get from the crowd sensing? We get, for example, the parametric about the location, about the velocity, how many mobiles are on the highway, which we can use, for example, also for climate changing. So we can say too much vehicles on the street with normal gas, or we can make all pictures how the guys is looking, holograms, and also you can also look to the menu card, and in the menu card you can say how much sugar is in it, or how much carbon is in it, or other topics. So with sensor technology you get a lot of data, and the very important point is here that it's not a camera, so this means that it's also data safe. Extremely connectivity, I already mentioned, we have the 1 terabit as peak data rate. Then we have a lot of sensors inside, and our requirement is, maybe I'm looking to the EC, they also said we need a better battery. We are now saying we need 20-year lifetime of the battery, but this is, I think, only a topic of the material. Then we have to reduce the latency, including the reliability, and also with a wider bandwidth, and so we can also reduce the sensing resolution. And then guaranteed data rate 10 to 100 gigabit. Then the reliability, we are saying now 7 nines, not 9s, what we have seen on the first day. The position accuracy can be increased, and the network capacity. So that is a feature which I like. Maybe Orange every time said connects the unconnected people. And here we have the possibility to connect the unconnected people, which is also using in the war between Ukraine and Russia. If they have no terrestrial networking, then they can make no communication. So this means that is very important. So we are saying here that we have to satellite to terrestrial in the very low Earth orbit. This means around 300 kilometers. That is in the microwave area. And Elon Musk said he need 12,000 satellites, very small satellites, that's like a shoebox. And but the point is that it's not in a stationary orbit. You must control it every time. And if you have a connection to a satellite, that is only 7 minutes. So this means after 7 minutes, you must connect to the next satellite. This means that we have also in the satellite edge computing. If we have not edge computing, then we must bring the data to the Earth to compute, stores, and so on. So this means these satellites, they will be a very clever, excellent, smart system. And the interconnection between the satellites is around 600 kilometers, and we have no dust there, so that can maybe done by FSO, free space optic. This means optical communication. And we need this also. The car industry is very interested for autonomous driving. Also, I think For climate changing, we can, with sensing, so we can send the data via the orbit, and so we can supervise the countries how much CO2 they are using, or is the consumption. Yes, we have a lot of possibilities, and we can also make the trading. Yes, so we can also make the trading better, and we can also support the agriculture, because you know that there exists a prediction that we have by 2050 more than 10 billion people, but we have only one Earth, so this means our production in the agriculture must become more efficient. So for the time being, we have also a problem with that, but I think that will happen, that will finish. But so maybe we can also use it as a non-terrestrial network also for the improving of the agriculture, which is useful. So then I come to the trustworthiness. We have to do something. There exists a possibility that we can use, for example, art of blockchain, that we each protocol mechanism that will be checked by blockchain on the same level or on the between level. But this point is need computing time, need storage, need also additional energy. But we can fulfill that everything is traceable. That is the most important point, that we can recognize is there an attack or who has changed it, so that we can say is traceable. Yes, then I coming to a topic about sustainability. Here, we are now here around this, so we have a constant CO2 print, food, and that is 6G. And now 6G will be around 2030 to, I want to say 2050 around, that's the lifetime, and the temperature is increasing. Up here to you see 2 degrees, 1.5 should be. If we're doing nothing, then we'll go to 3 degrees, and then I think we will have a problem on the Earth. 3 degrees. So maybe with 6G and with the sensing technology and with the integration of the non-terrestrial network, we have the possibility to make not too much increase at the temperature. But we have to learn it. But we have to learn it now to make the system available with the right artificial intelligence system in order to support the non-increasing temperature of the Earth. Then we will see in 6G vertical and new vertical business possibility. So for MBB, we will have around 6 billion devices with low latency for maybe for augmented reality or virtual reality. You know that each year 1.5 billion smartphones are produced. That is a huge number. Then we have to support the autonomous driving industry. We will have in the world around 2 billion cars which are on the time being on the road. They need approximately 1 millisecond and shorter, including the robots. Then 1 trillion is the number of sensors which we will have worldwide. That is a huge number. And that is here, what is that? 2 billion components for AI. That are the server farms we need. So that's a new element in the 6G if you want to have AI. That are the servers which belongs to Google, Amazon, Microsoft. And I think in Europe we will make a reindustrialization. Maybe we lost a lot of computer companies. If you're looking back, we had Mr. Suse, but we have not some additional guy in this area. So these will also 2 billion, that is a business also for NVIDIA or for AMD, but no German company or European company, maybe NXP, but they are doing more than that. I think NXP will go in this direction here, and we have a car, which European car maker, which will use this one with some 6G or 5G technology. So then, industry uses here. Everybody can have a robot, one robot or two robots. I have one robot at home. It's Echo from Amazon. I say news, then he gives me the latest news. I say, please play the song, he will do it. It's also a robot. It's the Amazon Alexa. So that is also a huge business field with AI and also some technology, wireless technology. Good, then I will go to the features which is called ISAC, Integrated Sensing and Communication Enabling Industry, Internet of Things. And here you see 3 robots, and they must communicate each other. There exists a possibility that they are pre-programmed and then they have to work, and after they have finalized the task, maybe for 1 year, then they have to reprogram. Now we are saying how we can do it. So each robot has a terahertz device. It's called maybe terahertz camera for sensing. You see he sends it. Then the next topic is to make communication between the robots, between the devices. And then we also introduce, because that is better, we are using here optical wireless communication. With optical wireless communication, we have higher distance. Maybe for our testbed, we are using distance of 2.6 meters. For the sensing of terahertz, we have only 30 centimeters. So this means that this is a combination for optical wireless and for terahertz communication. And that is maybe the tool which has to work by the robots. So what is for the time being is ongoing? We have 2 robots, they have to work together. Then the first one is doing something. Then the second one is doing something at the end, in the last step. No? They are ready. So now that's a pre-program. And after the process, you have to pre-program, you have to send up a new software, and to make the administrable, you have to do a lot of things. So now, if we doing integrated sensing and communication, that can become a little bit easier. We have here the communication color is green, and for sensing we are using red, and that is the tool which have to work. No. So first they are doing sensing, they are looking where is the tool, where is the equipment, what I have to do. Then they're making communication each other, and then they are ready with the tool. So it means it's very easy in the picture, but we have to do it also in reality. Now I want to look why it doesn't work. Okay. That is our test or our showcase in the booth. You see here. Okay. You see here. That is, we are using for this positioning optical wireless, because you can do it very well with optical wireless, and because we have to control the robot get a package, you put it on the robot, and the robot has the task to bring it to a second robot in order to make something with this. Then I look where I have. Yes. Do you see the robot? the first robot here broke the package to the second robot, and the second robot will use it. And that is the terahertz module, which is doing a sensing of the contents. That's a black box, and we have no information what is in. Do you see the first step? The advantages this year, we are doing a 2D scanning, 5 minutes, and we get a 3D picture based on reflection, based on the mobile, maybe about the mobile channel which we have in this box. Okay. So it's now going back. Okay, and then you see here the optical communication, which is using for the transport. So, I have 5 minutes, Louis said to me. I think we can. So, one challenge is the spectrum research. We have to look what we will see in the macro cell, so maybe in the centimeter area, which frequency we will have in the millimeter area and for the satellite, and then for the whole number or billion of sensors, which system we want to use for sensing the whole area. So it's next one. That is a picture which is very important. In order to fulfill the GDPR, the models, they have no data. So this means we have to log the data, and only we can exchange the modules. The intelligence, the AI modules or the intelligence, we have to exchange it. And we have to look how looks like a neural manager. He can make the exchanging of the artificial intelligence models, and how we can log the private data, because the private data should not leave the private zone. So then, with deep learning, that is an additional task. For additional tasks, we need additional energy, and our calculation is saying that we have to double the computing energy. And another topic is, if you're going in the millimeter wave RF technology, the efficiency of the millimeter wave RF technology is not very efficient. Maybe we have here one material that is very efficient, that is development by the Fraunhofer Association, and we have some photonics that are also not very efficient, because this is not very efficient. If you have some, the efficiency is only 5%. We have to increase it. Okay, then that's one of the last slide. If you want to have a mass market, if you want to have jobs, if the jobs are distributed over the world, we must look how we can support a global standard. And not everybody is looking in his own mirror and say, I'm the best in the world. They have to work together so that the world has a very excellent system in order also to overcome the climate change. Maybe, for example, EC is supporting with 900 million euro only for mobile location, also additional money for other topics. Germany around 700 million euro, Finland 200 million euro, China a huge money, about more than 2 billion, more than 2 billion euro, and Japan and Korea doing also a lot. And they have to work together in order to find a good system. 6G will integrate Can you switch on?
Deep edge architecture enables massive machine learning in a
I
distributed.
will repeat it once again.
6G will integrate sensing with communication in a single system. Radio waves can be exploited to see the physical world beyond eyes. Such capability offers autonomous driving vehicles ultra-high resolution and accuracy in all weather conditions. What's more, high-precision localization and gesture recognition will truly free our hands and make art creation anywhere, anytime. 6G will boast its native AI capability. Deep edge architecture enables massive machine learning in a distributed and collaborated manner. Robots can thus harmoniously work and play with humans. 6G, the next horizon.
Okay, I think it's time to close.
I think we can sign up for buying a flat in these buildings you just saw. But before that, any questions you may have to?
It's good, then I can go on time in the coffee break.
Any questions to Egon? Yes, okay.
Ilaria Malanchini from Nokia. I think in a couple of slides you highlighted that we keep the data private and we share only the model.
Yeah.
So I understood we share a trained model or the parameters of the model, but doesn't that also imply some privacy or model ownership? Or if I'm a private business, why should I share my model? That also gives some information about what I have, right?
Yes, because you have to share the model, because we have also roaming. If you're traveling from one country to another country, who will know where's your model, or is part of your model integrated in the global model? I don't know. That is a part of research.
Yeah. I think that might also imply some willingness or not willingness.
Yeah. Maybe they, yes. Maybe there's also the possibility that you're saying, why should I give my data in order that the people make a deep learning? That's also the possibility. Just a switch on, yes or no, and then it's okay. It depends what you want, which performance you expect from the system. But most important is what we have the discussion with US and Europe. Most of the data now located in US based on the server. They can get all information if they want. That's according to the law, which the European Commission has agreed. That is important, that the data will stay where the people are living. That's the most important point. All other things we can discuss. That is a no-go. Yes. That's only to say that it's not easy. Also, now we discussed about the geopolitical, how we want to give our model to China or to US or to Russia. I don't know. But we have to do it in order to have a model, and then we can make the second decision, who should participate and who should contribute. Yes. But at first, we have to do our job. Okay.
Any final question? I don't see any. So, Egon, thank you very much again. Thank you.
Okay, thank you very much. That was a pleasure for me, and if I can come back next year, so maybe with 6+.
Yes, and even 7G, why not?
Yes,
Let's wait a few years.
Maybe the point is, what is 10 years after? Will we have the same communication system like today, or is 7G is that maybe more services? Because the frequency is also occupied.
We need many more editions of EuCNC to discuss that.
Yeah.
Okay, we have a slight change in the program. Tommy, so basically the slight change is the following. So Tommy Svensson is, as you have noticed already, the organizer of next year's edition of EuCNC and 6G Summit. He was supposed to make the presentation at the closing session in 2 hours from now, roughly, but his flight was changed, or cancelled and then changed. So he's going to present EuCNC's and 6G Summit next year's edition right now, okay, so that he can take the flight. So bear with us 10 minutes before we'll go for coffee, if you don't mind. And Tommy will just give you a brief presentation of next year's edition. Okay, Tommy, so the floor is yours. You have 10 minutes.
Thank you very much. Can I use this mic?
Yes. So then you have a shorter closing session, right? So don't worry about it.
Okay. Okay. Thank you for staying a few more minutes into the coffee break. There's a mess in the airplanes in Europe now, seems like, due to Amsterdam problems. So we were canceled, and there are no other flights until Monday. Okay, so thank you for being with me. I'm very happy to get the honor to be the local chair of EuCNC and the 60 Summit next year, which will be in Gothenburg in Sweden. It will be the same week and the same weekdays, so June 6 to 9. And it will be at the Swedish Exhibition and Congress Center and the Gothia Towers. So my name is Thomas Svensson, and when I'm not organizing EuCNC and 60 Summit, I'm a professor at Chalmers, where I lead the wild systems research. And I'm quite happy to do this local sharing because I've been involved in EU projects and EU communities since 2004, and I've been to a bunch of those conferences, and so I think this will be fun, and I hope you also think it. So the program structure is the same as this year. That's the starting point. There might be some innovations along the path, but the starting point is the same structure. And if you're interested to become a sponsor, we are working on that now. So feel free to approach us. We would be very happy. So after that, I would like to do a little bit some glimpses of Gothenburg. So we have a slideshow here, and I hope it works. Yes, it does. Okay, good. So some highlights of the city of Gothenburg. So the city is located, there's a river, Göta Älv River, and the old town is actually, there's also a canal around the old town part. But the north side of the Gothenburg is also developing a lot, so there we have the Gothenburg Silicon Valley with the high-tech companies, and the south part is the original city area. And then we have a very nice archipelago. So if you have the time to stay after. The West Coast is well known for its good fish and seafood. The water is very clean out in the sea outside there. So this is actually look like a church, but it's a church for fish church, we call it. And the shrimps is that's we are proud of. And the city is very green, so everywhere you see parks and trees in the city. This is a well-known amusement park called Liseberg, so an amusement park, but also very nice with restaurants and cafes and strolling areas. It's just on the other side of the exhibition center, the other side of the street. Then we have a Gothenburg Botanical Garden, and that is very varied with kind of trees due to the long history of trading in the world. So this train company has brought back trees from all over the world and built the garden. This is the dining area, I would say, the linear district, restaurant area, and this is the main square, the Poseidon statue at the Götaplatsen, the Gothic square, which is the south end of the long avenue, which is the shopping street. We turned 400 years last year. If you like museums, we also have some good. Maybe we can't compete with Paris and the Louvre, but still. We have actually quite many. The museum has mentioned in the Michel Guide. And this is also a school for design. We attract quite high-level musicians to the orchestra. Yeah, we had this again there. Okay. And this is the three towers at the exhibition center, the Gothia Towers. So they are an integrated part of the exhibition center, which is walking distance to the main avenue and all restaurants and so on. And you can go to the island, the archipelago, with the public transport. There are trams and buses all the way out. In the northern part, you can reach the islands by car. In the south part, only by passenger ferries. But as I said, they're part of the public transport system. We have a quite new opera house, and that's in the north end of the avenue, so in the very city center. A little bit about the industry and technology. The automotive industry is very strong. We have a strong hub there, both Volvo Cars and the Geely Group, and also Volvo Trucks, Volvo AB. We are proud of this ship. It's a replica of an original ship trading with Forest Asia in the 18th century. And actually, William Chalmers were co-owner of that company, and he donated half of his estate for Chalmers to create it was a carpenter school. So we have two universities, Gothenburg University with all the traditional faculties, well, except the engineering, because that's what the Chalmers stands for, and then we have some common departments for basic science, math, and physics, and so on. And this is the overview of the exhibition center and the three Gothia Towers. And this is from how the exhibition area can look like. This was a medical conference. And this is the auditorium. So the exhibition center, they have about 1 million visitors per year, at least before the pandemic. Okay, and then 1.5 more minutes. I want to show a video, and let's hope that we have some sound also then. Do you have some sound? No. No sound. Let's try if you have sound. It's 1.5 minutes, so I hope we have the time. I'll try to do it off.
Why do some things stay in your memory? We think that the details are as important as the big things.
Oh, then you don't have any.
We believe.
That's complicated. How do we fix that?
Why do some things stay in your memory? We think.
Should we skip it? Okay. Okay, so then I go to my just the final slide then. Okay, but the video is very nice. 1 minute 20 seconds. We don't have the time.
It's okay.
I
think
I will post the link.
Yes. So before Tommy goes to pick his flight, as you know, we have this tradition of handing over a flag. In the last 2 years, this was a virtual transition, but now we can really have a physical handover of the flag. So Emilio, this year's organizer, will hand over the flag. It's a huge responsibility, of course, to Tommy, right? Which is next year. So please, guys.
Good luck. Thank you.
Upside down.
The Marflow, isn't it? Okay,
You don't need to flip.
No, no.
No, now it's a mirror.
Okay, so this way.
No. Thank you, and thank you for very nice organization of this year's edition. I will build on your experiences, and we will do what we can to make it a enjoyable event. So very welcome to Gothenburg in a year from now.
Okay, so this concludes this first part of the session. Let's have the coffee break. I think we can be back 10 minutes after the time, so it's 10 to 11. Let's be back at 11:15, okay? 11:15, please. Thank you.
Okay, thank you.
Congratulations.
Yes.
All the best. Let's keep in touch.
Yeah.
Go and pick the flag.